What's going on, guys? Today we're going to learn about using the 555 timer for PWM control for high voltage devices. So what we've got here is a few components already installed. I'm going to throw up the schematic of how we're wiring this together. So obviously we have the 555 timer right here. It basically gives us our pulse width modulation. We've got two capacitors. This bottom one is just coupling pin 5 to ground, so it keeps it high. This one right here is our threshold capacitor. Basically the lower the value, the faster our frequency will be, and the higher the value, the slower the frequency, because it takes longer to charge. Our potentiometer right here is a 10K. Again, this affects the frequency of the pulse width modulation. If you go for a higher value potentiometer, it will be a slower frequency, and if you go for a lower value, it'll be a faster frequency, because it has to go through these resistors to charge and discharge. This diode right here basically lets us bypass RB on the charge cycle, and that lets us get below a 50% duty cycle. If you're not sure why, I made a video about that as well. Just go back and watch that video. It just goes into the theory of the 555 timer and how it works and how to get below a 50% duty cycle. So right here we have our voltage regulator. It is 7805. It will drop anything, I think, from 30 or 35 volts down to 5 volts. But in any case, we're only using 16, so it will drop the 16 volts down to 5 volts to make sure we don't cook our 555 timer. And last but not least, this is an IRLZ44N. What this does is it's basically a super high current transistor. We're going to use our 555 PWM signal to control this, and thus the brightness of this 16 volt LED right here. Now you're also going to need a power supply or just something just to supply your device that you're powering. I'm going to be using this voltage booster. It's already adjusted to boost up to 16 volts, which is what this LED needs. So we are going to just plug this in up here, and this rail on this side will be our high voltage rail, and this will be our 5 volt rail right here. Okay, so now to wire up the 555 itself, I'm going to wire it up and explain what I'm doing, and I'll also have a schematic for you guys to follow on the screen right here. Okay, so this potentiometer is basically our RA and RB resistors. So we're going to put in our white wire on this top here, and that's going to go to pin 8 right there. Then we have a blue wire going from the middle pin to pin 7, like that. Let's go right here. So there we go. Then we have a green wire coming from the last pin to pin 6 on the 555. So now RA and RB are hooked up via our potentiometer here. So now what we're going to do is we need to tie pin 6 right here to pin 2. And that allows for a stable operation. Then after this, what we're going to need to do is tie pin 1 to ground. That is just ground for the chip. We also need to tie pin 4 to voltage. So we're going to go from pin 4 to our 5 volt rail over here. And we also need to tie pin 8 to our voltage. So it goes from pin 8 to our 5 volt rail over here. And this is basically what the schematic looks like all done. So now we're going to hook up our voltage regulator. I don't think we need stabilizing capacitors on it right now since it's coming out of a voltage booster, but we are going to run ground from our high voltage rail to our regulator, and then our regulator to our low voltage rail. And then we've got the voltage, obviously, going from the high voltage rail to the input of the 555. And then from the output of the 555, I'm sorry, not the 555, the 7805, to the 5-volt rail. And then we are going to attach our IRLZ44 in. So signal, the PWM signal comes out of pin 3 of the 555, and it goes in to pin 1. That is our gate. Our drain is pin 2, basically the ground for the LED is what we're going to hook that up to, and our source is pin 3. Right there. We're going to take that down to that ground. Then our voltage for our LED is being fed off of that high voltage because we need 16 volts to drive it. So there's that. And that should be the full circuit for our LED. So let's go ahead and turn off this light. And I will plug in the battery. All right, so we've got power. Let's see if the PWM works. I'm going to adjust the potentiometer right here. Hey, there we go. All right, so we've got a working PWM. Now I'll have to check to see if this PWM frequency works with my shutter speed. I don't know if it's rippling or not, but if it's rippling, that means the frequency is too low and the shutter speed of the camera is catching that on and off signal that the 555 is feeding to the IRLZ44 in. But there we go, and we have a full duty cycle range because of that diode. There you have it. So I hope that helps you with one of your projects or something you're working on right now. I'd love to hear if you use this video or if it's helpful, so comment down below or just drop a like. That would really help me out. Hope everyone has a great day, and I will see you guys next time. Be sure to do something kind for someone today, and mix that up. Be sure to do something nice for someone today, and I will see you next time. Peace.